everyone, welcome to my video. I am Güven from 9F and today I'll teach you what Pythagorean theorem is. So what we'll be learning today, what is our plan? First, what is Pythagorean theorem, who proved it, what are some Pythagorean triplets, and some basic information about special triangles. So let's begin. Theorem only applies to right triangles, and it states that a squared plus b squared equals to c squared. This is A, this is B. It could be reversed to these are just the sides instead of the 90-degree part. The 90 degree is over here because it's a right triangle, and the side which is across is called hypotenuse, which is the longest side of a right triangle. These are some hypotenuses of a right triangle. It states that the square of the hypotenuse, the side opposite the right angle, is equal to the sum of the squares of the other two sides. We have a triangle like this side is 4, this side is 3, and this side is unknown, so this is our equation, a squared plus b squared equals c squared. In this case, 4 squared plus 3 squared equals to c squared. So 16 plus 9 equals to c squared. When we add them, it is 25. So we have to take the square root of 25, which is 5, so 5 equals to c. Three different proofs of Pythagorean theorem. The one that you're seeing now is the longest one. It's about similarities of the triangles. The second one is about creating squares using little identical squares according to the lengths A, B, C, and finding a relationship between the areas of those squares. This is the third and the last proof of the Pythagorean theorem, and this is the one that I'll be talking about it in detail. According to this figure, the big square's area is c squared. The identical right triangles and small squares inside the big square area sum is equal to the big square's area. So, we have to add the areas of 4 identical right triangles and small square's area. And they will be giving us the area of the big yellow square. So, the area of the identical right triangles is 4 times the area of one of them. And one of them's area is a times b divided by 2. And we also have to add the small square's area, which is b minus a squared. When we do the addition, we end up with something like this, but it's not done. We have a cancellation to do. When we cancel minus 2ab and 2ab, we have only this in our hands. A squared plus b squared equals c squared. The proof is done. So I wonder who proved the Pythagorean theorem? Well, Pythagoras did. He was a Greek philosopher. He was known as a mathematician and astronomer, so he studied math and astronomy. Do you want to hear a fact? Actually, Egyptians, Chinese, and Babylons already knew the theory a squared plus b squared equals c squared 1,000 years before Pythagoras' times. Since Pythagoras proved this equality with geometry, the theorem's name happened to be the Pythagorean theorem. Also, the formula was written by a Hindu mathematician, Badutayana. We have 3, 4, 5 triangles, 6, 8, 10, 5, 12, 13, 8, 15, 17, 7, 24, and 25. As you all notice, they actually include our theorem a squared plus b squared equals c squared. So when we look at this triangle, we can call it 3, 4, 5 triangle. Well, it's a Pythagorean triplet, so how can we make more Pythagorean triplets? Well, we can multiply or divide the same number with these, so 3, 4, 5. So we can multiply all of them by 2, or if it's a bigger number, we can also divide it by 2. We can do whatever we want, but we just have to do the same thing for each length. We have 3, 4, 5, so we can multiply them by 2, so 6, 8, 10. Well, it's also a Pythagorean triplet, which means they actually include the property, which is a squared plus b squared equals c squared. Why are Pythagorean triplets useful? Well, there are two things mainly. So first of all, when you have a question like this, you don't have to do calculations and waste your time because these are big numbers. So you can just memorize the Pythagorean triplets and then find the answer easily. So we have 9 and 12, and I memorized a Pythagorean triplet, which is 9, 12, and 15 triangle. So it's 15. Also, you can find a connection between Pythagorean triplets. Well, for example, in this question we have 12 as one side and 16 as another one, and C side is missing. So did you realize, first of all, let's remember, we have a triangle called 3, 4, 5 triangle. So when you multiply all of its sides by 4, you end up with 12, 16, and 20. So C It matches. We have 12, we have 16, and hypotenuse is missing. And if we multiply 5 by 4, we end up with 20. So 20 is C. It's our answer. Not say x equals 13 by thinking, oh, this is 5, 12, and 13 triangle. Well, boom, we would get a 0. Well, in that triangle, 13 is the hypotenuse, but in this one, 12 is the hypotenuse. So you can't just say x equals 13 because those two triangles are not the same. So you just have to apply the Pythagorean theorem, which is a squared plus b squared equals c squared to find x, which is square root 119. There are some special triangles and they help you to not waste time doing calculations. First one is isosceles right triangle. As you can see, this side across 90 degrees is x times square root 2 and the side which is across 45 degrees is x. Find the hypotenuse by doing the Pythagorean theorem, and as you can see from the picture, this is how we find it. Another special triangle is 30, 60, 90 right triangle. So as you can see from the figure, this side which is across 30 degrees is x, the side across 90 degrees is 2x, and the side across 60 degrees is x multiplied by square root 3. To find the hypotenuse, you can also use the Pythagorean theorem as is shown below. ABC triangle, AB is perpendicular to BC. BC is 12 centimeters, AC is x plus 8 centimeters, and AB is x centimeters. Find the value of x. Since AB is perpendicular to BC, we can understand that this is a right triangle and this is 90 degrees. So we can use Pythagorean theorem, which is a square plus b square equals to c square. In this case, if we say ABC for this, x square plus 12 square equals to x plus 8 square. So it is 144, and this one is x square plus 16x plus 64. We can just cancel these and put this one to here. So 80 equals 16x. That way x is 5. 8-meter letter rests against the wall. The wall's height is 3 meters. Find the value of x in the figure below. So again, this is 90 degrees, so we can use the Pythagorean theorem, which is a square plus b square equals c square. So this is 8, this is 3, so we have to be careful. This is the hypotenuse, so 3 square plus x square equals to 8 square. 9 plus x square equals to 64. When you put this 9 to here, you have 55. So if this is 55, then x equals square root of 55. I'm just gonna leave it like this. The triangle AC is 13 centimeters, BD is 6 centimeters, DC is 12 centimeters, and AB is x centimeters. Find the value of x. So first here we see two triangles. First we have to find this one because there are two unknowns now. We can remember the Pythagorean triplets, so 5, 12, and 13. So I'm not going to do any calculations because I already remembered, so it's 5. So we just have to do Pythagorean theorem for this part. So a square plus b square equals to c square. 5 square plus 6 square equals to c square. Or we can just say x because now in here it is x. 25 plus 36 equals to x square. And when we add them, it is 61. We have to take its square root to find x. So this is our answer. Since the question is too long, I'm just going to summarize it. There is a plane, and first it goes this much meter, and then this much meter, and this much height. This is a control tower, and it's 90 meters, and this is the total amount of height which the plane got. So it asks us to find what would be the distance between the plane and the man on top of the control tower. So first we can understand that when we add them up, it's equal to 7,200. So this part is 7,200 meters. We also know that since this part is 90, then this part has to be 3,000 because in the question it gives us the height. So we have it. As you see, we're dealing with big numbers, so I'm just going to use the Pythagorean triplets property, so we can divide these to the same number, and if it gives something that satisfies, then we can see that. Now this is our triangle, so we can divide it by the same number, which is 100, and when we do that it's 30. When we divide this by 100, we have 72. we can divide it by 6, both sides. This is 5 and this is 12. So now actually our triangle looks like 5 and 12, so it asks us this part. As you realize, this is a Pythagorean triplet, so this part has to be, since this is the hypotenuse, it is 13. But when you look at this figure, we also have to multiply what we divide before. So 13 times 100 times 6, which gives us 7,800 meters. Is our answer. AD is 15 centimeters, AB is 4 centimeters, and CD is 8 centimeters. Find BC. So it is given that AD is 15 centimeters. Well, when we draw lines, a rectangle is formed. As you can see, when we draw a line like this, it's, yep, like that one. A rectangle is formed. We drew it to find AE. Let's call this part E. So we know that this part is equal to 8 as well, and also this part is 4. So when you add them up, actually you have a triangle like this, 12, and this part is missing since these parts are the same, and 15. So our question turned into a basic Pythagorean question. So this is our triangle if you look at this, because ED equals to BC, and we have to find BC, and we can find it by looking at this big triangle. So 12 square plus x square equals to 15 square, since this is the hypotenuse. So 144 plus x square equals to 325. 81, which is equal to x square, so x comes 9. By doing this project, I remembered the last year's topic, which is a topic of this year too. I solved various types of questions and I improved myself in this topic. If I could have 15 minutes for this project, then I could include more questions and that would be more educated. So we came to the end of the video. In this video we covered the topics as you can see here, and I hope you had fun and you learned what is Pythagorean theorem. Bye!